Welcome back and welcome to lesson 13 in the Houdini Environment Beginner Series. We're going to continue where we left off in the bottom section of this network, and we are going to extend to start preparing our newly created procedural model for Solaris. So what we're going to need to be doing is we're going to split out some of these pieces, subdivide and bevel some of the pieces we want to be strict geometry. So we want these wooden pieces, we want the door, and we want these window covers to be geometry as well as this garage door. But for the rest of the house, and then actually for this fence here that we just created in the last lesson, and for maybe the new piece you made yourself when you continued the exercise, we want those to be a concrete, so the single uniform piece of concrete. So we want those smooth transitions between the pieces and a nice little uniform object, which is really easily done when we use VDBs to remesh our polygons. Next, we're actually going to create some point attributes for occlusion, ambient occlusion, and we're going to store that on our object. And then we're going to manually save out a few variations. And if you remember from the last lessons, we've set up our system, our network here, to be procedural based on the frame number as a seed. So if we play this, we'll see all these different houses, really infinite houses, that we've created. And we want these to be able to not time shift. So we want them to stay still in time and not be flickering every frame. And we want to be able to manually move and place them so we can actually get our exact setup that we want for our environment. And this is kind of what we talked about, I think it was lesson 2, about having a procedural system, which in this case, all of this stuff, we don't necessarily care about these decisions. We'd rather have Houdini make a bunch of these for us go through frame by frame and say, hey, I like this one, or hey, this one I don't like too much. So we pick the ones we like, Houdini does the rest of the stuff for us, and then we just place and arrange our scene the way we see fit. So to get started, let's actually do exactly that. Let's find one that we think is cool and maybe has some fences. I want one with the fence and then another side as well. Actually, that one sort of worked. This will be fine for now. So this will be the fence one we have. What we're going to do is we're going to start going through this entire setup, and we'll see what we split out and why we're doing that exactly. So continuing here, this was what we've covered in the last, I think 5 lessons it was. We now have our entire house here nicely merged and organized. And if you notice, we do have a bunch of these groups. And one thing we've actually intentionally done is we've named these groups with an underscore building in front of what we know is important. So here, up here, underscore building underscore stone. And we did that because when Houdini actually is working on this data, it creates a lot of other groups. For example, with extrusions, and we've created a bunch of groups which we could have cleaned up earlier, but we've left so I can show you that you need to clean those up really before you cache any geometry and before you actually save anything to be used in Solaris. So you want to know exactly what's on your geometry so you're not getting unexpected results. And the way I do that is with a clean. So this clean node here can do a few things actually. But what I'm going to do is I'm going to use it to delete attributes and delete groups. And what I want to do is I want to delete groups, but I want to delete every group unless it has the name underscore building. So you can see this, building. So this will now delete every group unless it starts with underscore building. Now that's good, but we need to also keep some of the attributes because we have a few things that are important here. So we want to keep, actually I think the only thing we really need to keep is rand. Or maybe that was a different object. Actually, let's delete all those because rand I do know I used for the stone pillars to create some random variation on each of the individual rocks. But I'll actually also keep CD just for now. So here I have kept this one so I can see this color visually in my scene view. But Rand, what I was saying is on the pillar, I actually did keep rand to randomize some values in the shading. But for the house, I actually don't think I do that. So I'm fine to delete that one as well. And the cool thing about Houdini is if I do need that later, I can just come back and fix that, either keep it or remove it. Next up, we split by building stone. So again, just split here. We select which one we want to split. Stone is now going to split to the left. And now you can see here, we've got all these pieces. What we want to do is we want to remesh these all together, but we want it to be a little more smooth than if we just did it with a harsh corner. So what we do is we bevel first with a poly bevel, and I set it to distance, and then I did ignore flat edges, which is going to reduce some of the beveling here on similar facing normals. And then I recompute normals for good practice. I do a VDB from polygons to create our actual volume, which you see here. And I've actually had to set the voxel size, whoops, to be a little bit smaller. So I did I think it was 0.01, looks like 0.02 I did. So I reset our voxel size, and then I converted it back with a VDB convert, or a convert VDB it is. Connect it here to the first. And then what we do is you set the convert to from volume to polygons. And there we go. And what we can do is if we don't want all this resolution here, you see all these lines, we can increase the adaptivity, which will say for faces that are very, very similar, then you can pretty much assume they're similar and reduce some of the geometry. So that is now 239,000 points. If we delete this, that will be a lot more. So there we go, 788,000. So we want this one because we don't want to store those many points on disk because we don't actually need all that information. And then we do a UV unwrap, which is again one node we've done before, which is Houdini's way to create procedural UVs. And because we are actually creating UVs with the intention of using tileable textures, we don't necessarily have to worry about our UVs, but if we were doing an asset workflow or we needed to bake out curvature maps maybe to UV space, we would want to be a little more organized with our UVs. I'm going to disable our wireframe. So here we go. This is our building. We've transformed this to change the scale. And again, I've mentioned before, since we are using infinitely tileable materials, we could do the changing of the scale either in our UVs here, or we could change the tiled texture repetition in our shader. And then we recreate this group. The reason we actually do this is because I don't think, you see Houdini does not save this while we're doing volumes. So we recreate this group so then we can later use it to define a name attribute. Whoops, I accidentally clicked here and it's going to cook. So I'm going to hit escape because I was trying to cook the ambient occlusion, which we don't want to do yet. So we use this group to create a name attribute for us to later then import into Solaris to surface. And you'll remember that from lesson 1 of the beginner series. So then about here, we've got this split, which then splits out the other side of the object. So anything that's not building stone, which we now know is our garage door, our main door, our human door, and then our wooden planks for the windows, and then our wooden blocks that we want for our little structure inside the top of our building. So UV unwrap, UV transform, poly bevel to give some extra resolution. And this is to get some of the smooth sides here. So if I disable this, you'll see it's very harsh. And that's one thing about 3D. Nothing really in the real world, in the physical world, has perfectly harsh edges. So it's always rounded, whether that's by the tiniest amount. So I always recommend you do some kind of bevel for just about everything. And then we do a normal and then divide. And the reason actually I do a divide is I wanted to create some, I think I actually didn't need it here. But what I wanted to do is I wanted to get more geometry here, because this masked by ambient occlusion, what we're actually going to do on this side is we're going to store a point attribute I'm going to create a null so I can see this without seeing this orange, which it looks like it's not letting me do. So I'm going to select here. But that orange was just in this group. What we want to do is we want to create a point attribute, and we want to store that on our actual individual points and then read that in our shader. And the attribute we're going to later store is our ambient occlusion attribute. So if I actually select down here, it'll cook for a second, which means Houdini will think, and then there we go. So now we can see we have this dark areas around the insides of these crevices, around the insides here, and then inside here. So this gives a little kind of a fake look at what buildup might be. Maybe it's wear and tear, maybe it's dust and dirt and everything. But what I needed to have was on these objects here, you can see there's no geometry inside these big panes. So technically, if there's no geometry, then there's no location for that attribute to be stored. So I could then create this ambient occlusion, which you see here. But now you see if I hit wireframe, there's no data in between these points for that ambient occlusion mask to be stored on. So in the shader, it's going to guess between the near points. But what I want to do is I wanted to give it resolution. So then this garage door here can have a little bit more of an opportunity to get some of that data and then to save that across its individual points. And the way I did that was I needed to add resolution to this. And the way I chose to add resolution to the object was with a divide node set to Bricker polygons. Which I could set here, maybe again to 0.2. And this was a way to nice and evenly cut the polygons here to give me more resolution for point attributes to be stored on. And when you bake textures, you usually would bake those into textures for the purpose of not having to have these point attributes. Well, not necessarily true, but these points let us use attributes in the shader, and we can kind of fake some of the effects that you would do with baking maybe curvature maps or ambient occlusion maps, just directly in Houdini and in a very easy to manage way. This rest, also we've learned in the material lesson, is for projecting a world noise later to blend between dirt. Actually, on the garage door, we blend between, I think, 2 types of metals. Here we blend between a concrete and I think a plaster material. So it gives some variation and helps these blend in a little bit better with the rest of the environment, and even to make a little bit more of a dynamic setup. And here we go. So now you see on these objects here, because I have all this resolution, we can actually see some of this ambient occlusion mask coming through on our objects. So you see on this door, we see some nice dark areas on the corners. We see some nice gradients from the outside here to the inside. Actually looks kind of cool. On the fence here, we see some cool stuff. And then if I did not have this, so you see right now, what I'll do actually is I'm going to take a quick snapshot, and I'll just do 1. So I'll take one image. I probably could do a screenshot, but it's going to recook this. Then hopefully mplay will pop up. And now it's recomputing again. Okay, well that was not the best way to do it actually, because it recooked the frame as I was animating. But what I wanted to show you essentially was here we see all the resolution. If I disable the divide, it'll disappear. So you see it's dark. Enable this divide, and then I'll get more places for the data to be stored. So it gives me a better result because there are these extra points to have data stored on. And I could hide the UVs by clicking this button. That looks pretty cool. So now I hope you can kind of start to see that simple things such as volumes and boxes and cubes, and even this fence was really simple, but it adds a little bit of detail. And I'm going to let you hopefully take this further and get some super detailed modeling if you want to go that far. So next up, we've got this rest attribute, which I just mentioned. We save the rest position, and that's so if we animate this object moving in our stage space in Solaris, we can reference a static location for the blending of the materials. So we're not going to have any texture painting or any shading artifacts of materials as the object might move in space, maybe if we were rotating it on a turntable, for example. So then next up, I have a mask by ambient occlusion. And then this is a node where I've created not a mask. I actually renamed it to, I think it was something else, shade mask. And then I did a color where I actually colored based on that mask. And I played with a few settings here. I'm not going to dive into this, but you are welcome to mess around with this if you'd like. But I, also did an attribute blur to blur a little bit because I didn't quite get as smooth of a transition as I wanted. So I wanted a little bit more of a blurred, obviously, look. So I blurred it, and you can kind of mess around with the attributes as you'd like. You could also map maybe the world position or hand paint some damage onto the rock if you want to blend with a blended dirt destroyed rock material. So the next up, we are going to take in our objects. We are going to blast the metal. Actually, I'm going to pause and I'll be back in just 1 second to continue this. Excuse me. All right, welcome back. And we're going to continue by preparing our geometry actually for Solaris. And the way we're going to set that up is we are going to take all this incoming geometry and we're going to split it up and give it a name attribute for each of the objects. And actually it looks like my setup here got a little messed up because I was moving stuff down. So firstly, I'll actually clean that up a bit and then we'll keep going. So I want this down here and I will leave this section down here. Awesome. So what we have here is we get our full house incoming here. And if we remember, we've saved these groups, which we've created previously on the different parts of our object. So here we've got our building metal, our metal door, our stone, which was this VDB remesh we did earlier, our wood, which we're actually going to use the same wood material for the windows as well as these interior wooden beams. And then we have, looks like building window. What this actually is, it's a setup for this window and it's empty now because this random variation of the house happens to not have a window. So if I keep switching forward, I'll eventually get to a frame, looks like this one here because I can see it cooking, that has the random probability set for one of our windows. And there we go. There are our windows. And then we name, so we name these right here. We did building metal, which is what we named our metal. We did building metal door, metal stone, or excuse me, building stone, and building wood. And the important thing here is that it's a name attribute and it's also on the primitive class. So then we merge these together, we'll get this setup. And I actually think our window frames, there we go. So our window frames also have the same group. So they got assigned the same building metal. So that means that when we assign our materials in Solaris, this garage door as well as these window frames will be able to have the same material assigned easily. And then what we do is we time shift. So we remember from before, and I'm actually going to go above here so we don't have to recompute our VDBs every frame. We remember from before that our seed for this whole setup was done by a frame. And it looks like something's below is selected. So I'm going to give it a second to cook, but now we're actually recomputing everything below. So I'm going to put my selection instead of on this metal here. I'm going to select a node above, and now I should be able to pan through a little bit quicker. So let's pick out some frames for what kind of door we actually like. And you're welcome to actually pick your own. So maybe find a few that you like, and then we can create a new setup with maybe a few more buildings. So let's do 186. So I'm going to go down here on my time shift. We'll give it a second to think. And set this to 186. It's also going to think again. So I could actually set this to a manual update if I wanted to, but I don't mind waiting, so I'm just going to leave it here. And then I'm going to save to disk. And now it's going to think, it's going to recompute everything above, it's going to recook, and there we go. And now if we pan on our timeline, the house is stuck. So we're not going to get new variations for each frame because we've saved a single frame to disk. Now let's go to another one. Let's go find, let's do one with maybe, I liked that one. Actually, this is a cool one. We'll do 106. So now we'll go back down here. I'm going to hit escape because I just selected this. So I just canceled the cook that I was about to do. I'm going to set this to 106, hit enter. Then I'm going to hit escape again to cancel that cook. Select the cache, hit escape one more time. And now it's loading in this geometry, which is the old one. And what I want to do is I want to recache. So I'll save to disk and that will recompute everything above and save our new building. We'll give it just a few seconds and there we go. So now I've got one house here, one house here, and now let's get a third house with a fence. So this new fence is what we added in the last lesson for lesson 12, and you are welcome to create your own addition to the house if you'd like. So let's go here, but we chose to do a fence, which isn't the most exciting, but I wanted to showcase the basics of how you'd extend that setup. Let's find maybe one we can get. This will be good. So now we get a garage. We got an external garage, the door, a human-sized door, a dome, and then we got this little fence here. So now I'm going to go down. This is frame 174. So I'll select down this cache, select the time shift, and it's going to recook again. So I could let it go, or I could hit escape to cancel the cook. And it causes these errors, but that's fine. So I'm going to do 174. I'll let it cook this time. And then what I'm going to do is I'm going to save to disk. And there we go. Now if I click merge down at the bottom, we can see this is where our newly created houses are. So this is what I was mentioning earlier, when we now have the flexibility to place each of these houses one by one. So if I wanted to keep that facing maybe this direction here, and maybe actually what we want to do is let's create a fourth house. So let's do maybe a house on this side here. And the way we're going to do that is actually, I'm going to double check because it looks like there's a time shift here. I want to make sure it's not messing anything up. So I want to make sure all of these houses are cached in the correct way, which it looks like they are. All right, so I'm going to go Alt drag to duplicate a new time shift. I'll give it a second. And this one, we don't really care what it is. So let's just do, let's do frame 227, just for fun. We'll give it a second to think. And then we're going to create a new file cache node. So here we go. We're going to do a new file cache. So file cache, connect it here. And if you're thinking about these colors, why they're not the same, you can hit C and then you can control drag to change the color of the nodes, and then when you create a new one, it will respect that color. Or you could just click to change the color of a single node. So I'm going to set this to house V4, and then I want it to not be a simulation. I want it to not be time dependent. So I'm going to uncheck this, and I want to delete hit name, and I just want to save it to OS, which is operator string. If I middle mouse click, you can see the name is now going to be house underscore V4. And this is something we've learned about before. So save to disk. Now what I'm going to do is merge it down here. With the Alt click, I just created this new little dot. But I want to do a transform. And I want to move this to a different spot. So let's put that maybe here. And let's rotate Maybe we'll do by 60 degrees for this one, so it's not the same angle. So it doesn't have to be a right angle. That's up to you to decide on how you want to set up your layout. And then one thing we should actually be aware of is our ground. So what we want to make sure is that it doesn't go too big, bigger than our actual podium. And I'm going to clean these up a little bit. And what we have here is actually our podium here from the other geometry context. And if you look, this is OBJ, so object context, podium geometry modeling out dirt ground. And we can see we're bringing this in. If I click this little jump arrow, we've already learned before, that'll take us to that area. So I'm going to go back with this up arrow here, which will take me back here. And then what I'm going to do is I'm going to template these two to see how they fit. All right, it looks like we need to get some space around here so they all fit together. And what I could do is merge or transform all of these individually, but I'm fine with doing a transform here. This will let me move all 4 houses at the same time. And there we go. Now all 4 houses have been moved with this one transform. And then what we do is we bring in this object. So we've done an object merge. And again, we fetched this object here, which is this, actually not that one, excuse me, this dirt ground here, which is the dirt that we're actually going to use in Solaris and Stage to shade as our natural dirty ground material. So I'm going to hit the back arrow. Actually, I'm going to Control C on this node to copy it. And then in this setup here, we can actually do Control V on our object merge, which will now merge that object in. We'll connect that to our wrangle. And now what we do on this wrangle, which you actually learned about this XYZ function before, we're going to do a distance, compute the distance from every point on this incoming geometry. And we're going to get the distance, we're going to remap it from incoming from 0 to 2 to 0 to 1. So we want to say any function or any point here, and I'll show you with this color, that is 0 units away from our object. We want to do a value of 0. And then anything that is 2 units away, actually, we want to set that to 1. And then the way that actually is remapped here is 0 to 1. So 0 is 0 and 1 is 1. And if that makes sense, I'll actually redo it, because I want you to know exactly what's going on. So we have to get every single point in this geometry on the left, and we want to get its distance to the geometry in this input stream. And actually, I could do this. So right now it's coming on the second input on this wrangle. What I can do is I can put it in the 4th input, because I'll show you, you can actually do multiple inputs for the wrangles, and you can just access these differently. So I want to say float dist equals XYZ dist, and I want to say get the position on geometry input 3, which is now 0, 1, 2, 3. And I want to get the position from P. Now what I'm going to do is I can do f at dist equals dist, which will now save this variable into our spreadsheet. But what I actually want to do is I want to remap this. Instead, from the actual value here, I want to make it a little bit more manageable. So I want to put it between 0 and 1, because 0 and 1 is easy to work with. So the way I'm going to do that is I'm going to do a fit. So I'm going to do fit, which is similar to the fit 0, 1 we've done before, but fit lets us set a minimum on the input and then a minimum also on the output. So I want to say fit a value from, we can see here, it says fit the value. So I want to fit distance, take it from 0. Maybe the farthest away we want to be is, let's do 3 units. And I want to fit that from 0 to 1. And this will say anything 0 or less than 0 is going to be 0, and anything 3 or more than 3 is going to be 1. And now what I can do is I can create a new color node, preview this, and then go to ramp from attribute, and then do our dist, which we can see here, dist 0 to 3, 0 to 1, and now we can see this attribute here. And I actually named it underscore shade underscore height, which was a little bit easier for me to remember on the spreadsheet what exactly, or not shade height. Yeah, shade height it actually was. Well, let's figure out where our shade mask came from. So let's color and we'll see what our shade mask was. That looks like it was the ambient occlusion we had calculated earlier. So up here for ambient occlusion, yep, looks like we calculated that and saved it to shade mask. So that's good to know. And that's, I even forgot actually what shade mask was. All right, here we go. And there we go. And this color node is actually not being used later, and that's why we're not connecting it to the output. This was just for me to preview what happens. And then also if I did a transform on this, and also Shift S, if you've been watching these videos, that's the way you switch between these wirings. So I like this kind of wiring, but you can choose either way. So if I transform up and down, you can see that it recomputes the attribute here for the XYZ distance. I'm going to delete this. And there we go. House out, and it does have this attribute. So awesome. That is going to be the end of this lesson, and it's the end of our geometry prep. Excuse me. The end of our geometry prep. I'm going to select this node here. And then next up, actually what we're going to do is we are going to continue and I believe actually start the Solaris layout, and we're going to start getting into setting this up for stage, setting up our basic stage, and then continuing with some other exciting things, and then even actually we're going to bring these back and do some cool procedural stuff for our rocks and our scattering of plants as well for this one. So awesome. That's going to be the end of this video. Thank you so much, and I will see you in the next one.